Hello, math lovers. I've been given this statement and asked whether it's true or false. The average rate of change of a function q with respect to t over an interval can be symbolically represented as change in t over change in q. Well, let's see what we can figure out. We're talking about average rate of change or slope, function q, which is the input q with respect to t is the output, over an interval being a space between 2 points. So if this looks an awful lot like the slope formula here, change in y over change in x, which is equal to m slope, which is y2 minus y1 over x2 minus x1. So I'm going to go ahead and change these variables so it fits what we're trying to find. Slope is equal to t2 over t1, the output, over q2 minus q1, the input. So I've created a graph here with two random points on it. We have t, our output axis, and q, our input axis. The 2 points, 2 and 3, and the other point, 6 and 1, and the interval in between, and we want the rate of change over this interval. These 2 points could be on a curve or a straight line. We don't know. We're just concerned about the rate of change between the 2 points. So I'm going to go ahead and take our pairs and plug it into this formula. I get slope is equal to 1 minus 3 over 6 minus 2, and I get negative 2 over 4. So we can see that as t decreases by 2, and it increases by 4 to get over to this point. So that's accurate. But we're going to go ahead and simplify our slope to negative 1 over 2. So I think that proves that this is an accurate statement. Now I'm going to use slope-intercept form to translate this information as well. Well, here's our slope-intercept form, y equals b plus mx, where b is the y-intercept that we don't know yet, which is when q is equal to 0, what's the value for t, the output value for t. So we'll go ahead and change this so it makes sense. T equals b plus negative 1/2, our slope, times q. Well, let's take one of these pairs. We'll take 2 and 3, and we'll substitute it for t and q. And what we get is 3 is equal to b plus negative 1/2, our slope, times 2, our q value. That changes to 3 is equal to b plus a negative 1, or 3 is equal to b minus 1. Now we're going to add the opposite of minus 1 to both sides to isolate our b, and what we get is 4 is equal to b. Well, now we know our slope-intercept is 4. So our slope-intercept form is t is equal to 4 minus 1/2 q. And sure enough, if we look at our graph, we can see that when q is equal to 0, our t value is 4. Also, our slope, negative 1/2, we can see that as t decreases by 1, it increases by 2. That gets us halfway, and again over gets us to our next point. So indeed, this can be used to represent this slope over this interval. So I would say the statement is true. Thank you.